Now we can talk a little bit about the periodic table, which we already kind of mentioned in class before about why or how the elements are arranged. They're arranged in order of increasing atomic number. So if you remember, that's the number of protons. So they put them in order of increasing number of protons, atomic number. So historically, how did they develop this shape of the periodic table? So what they did was basically there were two people working on this project at the same time, not together, just independently, and they kind of came up with very similar way of arranging these elements. And so what they did is they kind of put everything in order of increasing atomic weight, anything that they knew already, and they found that certain properties repeated themselves over and over again. And then if they kind of arranged those elements that had similar properties in the same column, that certain blank spots would show up, and yeah. So Mendeleev was a guy that here he goes. He left some blank spaces in his periodic table, and then he predicted certain elements. So he predicted that there should be an element. He didn't call it germanium, but he predicted that there should be an element here, and it should have this particular atomic weight, this density. It should be about that color. It wasn't known yet. They didn't discover it yet. So he predicted that there would be an element that had all these particular properties, and then when it was discovered, so here it is, right? So when it was discovered, and it actually fit into the periodic table, everyone said, yeah, okay, that looks like a great way to arrange these elements, more or less. And so they after looking at the atomic weights, they realized that if they just adjusted a few things, you can put them in order of increasing atomic number. By increasing number of protons, and so that's the way it is now. So they just had to adjust a few things. So Mendeleev, was credited as being the father of the periodic table because he predicted an element, and then when they discovered it, yes, it fit exactly where he said it would be, and it had all the properties that he predicted. Okay, so just looking at a sample box here, and the order of the elements is going to look the same, whether you have the atomic number on top or on the bottom or whatever. This could look different from one table to the other. You're always going to have those blue periodic tables to take the exam and the quizzes and everything, so just get used to looking at those. But the atomic number here, like for sodium, has an atomic number of 11. This is the chemical symbol. That's the average atomic mass. That's for all the isotopes that we just learned how to calculate in the last video. So there's a lot of information in each one of those little boxes. As far as other terminology related to the periodic table, each one of these rows, this horizontal rows, that's called a period. Right, so everything here, so as we move across, so anything in that particular row is a period. And then when you're looking down the columns, each column is its own group or chemical family. And some of those groups have names. These are called the alkali metals. Group 2 is the alkaline earth metals. Over here we have these are the alkali metals up here. Alkali metals. Metal. This is the alkaline earth metals. Metal. Handwriting is very bad. Right from here over, these are called the transition metals. These are the transition metals. And what else do we have? You see this staircase here? This is separating the metals from the non-metals. So anything downstairs, these are all metals. So we have alkali metals, alkaline earth metals, transition metals. These are sometimes called heavy metals. And then upstairs you have all the non-metals. So non-metals. This is going to be important when we start to name things. Non-metals. There we go. These are the these are the noble gases. These are the halogens. Those sorts of things. So we have to be able to look at an element and say whether it's a metal or a non-metal, and what family does it belong to. So we have those transition metals, right? Metals versus non-metals. We need to be able to look at a periodic table and say all of that. So let's try to just navigate our way around the periodic table here. So list the atomic number, chemical symbol, and atomic mass of the fourth period element in group 7A. So fourth period means row 4. And then group 7A. So you see these groups have different names here. 7A. You don't have to worry about that. They'll be labeled if we need those. So let's see. So 1, 2, 3, 4. This is the fourth row, and this is 7A. So we're looking at bromine right there. So bromine has an atomic number of 35 and a mass of 79.9. Right, so we can put that here. So bromine has an atomic number of 35 and a mass of 79.990. All right, so how many group 3A/13? So there's different ways to name those and different ways to number those groups. How many group 3A13 elements are metals? And then how many period 4 elements are transition metals? All right, so let's start with the first one. How many group 313A are metals? So group 313, here we go, group 313. All right, so we have 1, 2, 3, 4. So we're looking at things under the steps. So group 13 has 1, 2, 3, 4, because they're all under the steps. So that has 4. And then how many period 4 elements are transition metals? All right, so we have 1, 2, 3, 4, and then so this is period 4, starting here. And all these guys, if you count over, there's 10 in this row. So there's 10 transition metals in period 4. All right, so there were 4 metals, and then there were 10 transition elements. All right, so other elemental symbols. Given the name or the symbol of the element in this figure, write the other. So we should know some of these. You don't really have to memorize them because they're going to be listed on the periodic table, so I don't make you memorize them. Some of them you'll use a lot, and so you'll just remember them. Some of them have come from their Latin names, so like sodium, sodium should be S, well sulfur's S. So sodium comes from its Latin name. So these are all ones that come from Latin names, in case you were curious where they got these names from. All right, so now you can take a minute and try to, you can use your periodic table for this, try to figure out what all these are. So N is nitrogen, F is fluorine, that's an F, iodine. All right, and the symbol for carbon is just C, symbol for aluminum, Al, and copper is Cu. So you should practice looking some of those up. There's some